In this video, I will go over the MA162 exam 1 for spring 2022, and this will be the part 1 for questions 1 through 6. So for question 1, we have a sphere, and we're given the center point and a point, let's say right here, that's on the surface. So as we know, the radius is defined as the distance between a point on the surface to the center. So we can just use distance formula between these 2 points to get the radius. So distance formula, square root of, let's say this is point A and point B. We have 1 minus -4 squared plus -2 minus 5 squared plus 3 minus -2 squared. And all that would be our r, the radius. So that would be 525 -7, so 49, plus it's 525 again. So we have root 99, right? And then we can pull a 9 here. So, right, and then it would be 3 root 11, which would be option B for number 1 is correct. For number 2, we're giving vectors v and w, and we find the vector projection of w onto v. So here, the projection of w onto v would be equal to v dot w over the length of v squared times the vector v. A good way to memorize this, I would say, is whatever is onto, right? Onto v in this case, it'll be the dot product between the two and over the length squared times v, since the projection is, in a sense, it will be in the same direction as v. So if I draw something like this is w and this is v. So right, the projection like so will be in the same direction of v. So I will remember this as, here is the direction of v, right? Because you got to remember that in a sense it's multiplying by the unit vector of v. So the direction of v is here, and then the rest of v, and then this is just the dot product is just get the length here, right? So with that, let's just proceed. So it'd be the dot product would be 1 times 2 plus 2 times 3, which is 2 plus 6 over the root of so v be 1 squared plus 2 squared, which is 5, all of that squared, times the vector v. Simplify, so a on top, and then square root and square cancel, we have 5. So here, 8 over 5, and 16 over 5, which would be our answer choice C for number 2. For number 3, we're given 2 functions, and we're finding the region bounded by them. So first, of course, we need to graph this and get a sense of where these functions are. So by a glance, I can notice that the y-intercepts are both 3, since if you plug in 0, the y will all, for x, 0 for x, and then the y will all come out to be 3. So here, let's say 1, 2, 3, here-ish, we have a line with slope of 0.5. And then we have a parabola. Let's calculate the axis of symmetry. which would be negative b over 2a, which would be negative 5, 1.5 divided by 2 times 1, which would be, what, 3 over 4? So 0.75-ish. And since it's pointing upwards, the positive first constant can sort of draw the parabola like so, hit a lowest point here, and then come up sort of after, since it's symmetrical. But we do need to calculate this point where it intersects the line again. So we can plug that back in, plug these two together. We have 0.5x plus 3 equal to x squared minus 1.5x plus 3, minus 3 on both sides, plus 1.5x to both sides. We can get x equal to 0 or 2. Right, so those will be our bounds of integration. Right now, this area is what we want, bounded by these two functions. We can see that for this area, the red line is the top function, right? So it would be the line minus the parabola. So the area, we go to the integral of top function, 0.5x plus 3 minus the bottom function, dx. Alright, we can further simplify this. So we have 0.5x, just distributing, minus 3. Right, these two cancel out. We have negative x squared plus 2x dx. Right, so that will equal to x to the third over 3 plus x squared, 0 to 2. Now just plug in 0 and 2. We have negative 8 over 3 plus 4, minus 0 plus 0. So this would be, what? That's 12 over 3. So 4 over 3, which would be our answer choice A. Right? And that's a general thing. I don't think, usually, right, when you draw this thing, you can see that it's not 0, first of all. The area, there's some area right here, so it's not no area. And usually the area should not be negative. Area being negative doesn't really make sense, right? There's area, and there's it should be something there rather than being negative. Sometimes it might be weird because you're doing like negative dx. If your dx is moving like this way, then you might get some weird thing with your integral being negative. But since it's asking for area of region, area should most likely be positive. So if you had to guess on this question, make educated guess, right? Not negative and not 0. For number 4, we're getting 3 functions, and we're to use the wash method to find the volume of the solid that's generated. Of course, we're gonna graph this first, right? So we have y equal to 1. So y is this axis equal to 1, just a horizontal line. Right, x equal to 2, negative 2, straight down, and the exponential, I will use the same color. So usually exponential goes this way, but since this is e to negative x, you should just flip it around the other direction, like so. So it will cross x equal to 0 at 1, since if you plug in 0 here, e to the 0 is 1. So the area now we're interested in is this area bounded by these three functions and how it flips around, right? It would flip around something like this, around the x-axis, right? So it would be something like here too. Yeah, bad drawing. Right, it would flip all the way around. Sort of in a circle, and you get a washer, right? Uh, so here, for washers, we gotta remember it's the integral of pi, the bigger r, so r1 squared minus r2 squared. The whatever you're doing your integral with, might be dx, might be dy. In this case, is dx since we're flipping around the x-axis, so we are cutting the solid like slabs going downwards. So the dx here will be the really small parts of it. So we can plug in, right? We'll have pi r1, the bigger r would be the exponential in this case. So using negative x squared minus 1 squared dx. And the boundary integral, right, from negative 2 to 0. Right, simplify a little. Pi e to the negative 2x minus 1. This case would be option D. For number 5, we have two vectors and we try to find the angle between. So there's really two general ways of doing this, right? You can use dot product, which is the length times each other times the cosine of the angle, right, in between, or you can use cross product, which is the length multiply each other by the sine of the angle between. Right? Both ways generally will work, but let's use this first. Let's use dot product. Right? So if I a dot b, that is -1 times -1 plus 2 times 1 plus 0, which is that's 3. And then let's calculate a and b's length and put it on the side. So length of a would be root -1 squared plus 2 squared plus 2 squared, which is 4, 4, 1, so 9, root 9 is 3. Length of b, -1 squared, 1 squared plus 0, root 2. That's right. So in this case, cosine of the angle in between will equal to, right, a dot b over length of a times length of b, which is 3 over 3 times root 2. So 1 over root 2, which if you times top and bottom by root 2, you get root 2 over 2. You should be able to recognize that theta should be pi over 4 here. All right, 45-degree angle. So this is 45. Then you have 1 root 2, and your cosine should be what? Adjacent over hypotenuse, which is 1 over root 2. But this is not unique. If I draw a cosine graph, right, it goes something like this, right? It starts on 1, goes down at like what, pi over 2, 90 degrees, it reaches 0, right? But over here, it's the same graph. It's a even graph, right? With the answer pi over 4 is something like here, right? It's root 2 over 2. But as we can see here, since it's symmetrical at negative pi over 4, it also has the answer, right? Since we can't really plot this on like a 3D surface and really visualize the angle, at least I can. So I cannot differentiate between answer B or C. So I'm gonna use cross product to check my answer, right? So cross product here, sine of theta, we go to the cross product of A and B over length of A times length of B. So let's calculate a cross product. So A cross B, let's just do A cross B, equals to, let's see, -2, so I, J, K, -1, 0, which equals to, we'll have I of, you know what, the first column, 2, 2, 1, 0, minus J of -1, 2, -1, 0, plus K of -1, 2, -1, 1. Right, so we do diagonals. 0 minus 2, -2i, minus, let's see, that's 0 minus 2, -2j, plus -1 minus -2, which is 1k. So this is -2, 2, 1. So we want the length of this. The length of this would be what, plus 2 squared plus 1 squared, which is 9. Same thing up here, sort of. And root 9 is 3. So again, we have, plugging that in, 1 over root 2 again, right? It's the same triangle, we get theta is sine. Theta is 45, which is pi over 2. But if we look at the sine graph, right, we can tell it starts here, right, and then goes here, like this, sinusoidal, right? The answer we're looking here is 1 over root 2, so it's pi over 4, right? At pi over 2, it reaches a peak. But this time, for negative pi over 4, it would be negative 1 over root 2. So now we're sure that this is positive pi over 4, where we will get the answer 1 over root 2. So therefore, the answer will be C. For number 6, we have 4 points given to us on the edges of a parallel pipe. So these generally we're given 3 edges, right? They're all starting with the same point P here. So what we do is the volume would be the cross between 2 of them. I don't think I need that. Should be parentheses, PQ cross PR, and then the resulting vector of that dot the third edge. right? That will give us a volume. This is the dot product is a scalar, so that checks out. So here, let's just write out um, PQ, PR, and PS. All right, so PQ is Q minus P, so it's -1, 2, and 1. PR is R minus P, 0, 0, -4. And S minus P, 0, 2 minus 1, 1, 2. Right, so then we want to cross these two. So we have the cross equal to, so I of 2, 1, 0, -4 minus the J of -1, 1, 0, -4 and plus, right, okay. And then -8 minus 0, -AI minus, let's see, that's -4, +4, -4, and then plus 0. Right, so this resulting vector is -8, -4, 0. And then we dot this with PS. Dot these two together. Right, and then the result volume would be 0 plus 1 times -4 plus 0. Right, and since it's a volume, so we take the absolute value of that, which would be 4, which is our answer. Thank you for watching this video. The past exam archive and all the videos I did related to this exam will be linked in the description below. Please check them out if you're interested. Thank you.